Carbon, as we know, there are nearly 120 elements are there in our periodic table, but this carbon Hello everyone, welcome to Toppers Academy. So today we are going to discuss regarding the basic organic chemistry. So as we know, our chemistry is being subdivided into three units: organic, inorganic, and physical. So today we are going to discuss regarding the organic chemistry. So before reaching to that, we have to know the basics of this. Like when we study, like in class 11, when we have the basic concept of chemistry, in that we must we deal about the basics physical chemistry concept. So in the basic organic chemistry, we are going to deal with the basic concept which we are going to use in the organic chemistry throughout our syllabus. So generally it is very useful from the class 11 point of view and also from the class 12 point of view, because in class 12 most of our chapters like haloalkane and haloarine, alcohol, phenol and ether, or you can say oxygen containing compound, aldehyde, ketone and ether, nitrogen containing compounds such as amines. So all these, like in all these chapters of class 12, so this basics of chemistry we are going to deal again and again. So if our basic is weak, so it is quite difficult for us to proceed with all these chapter of class 12. And in the class 11 also we are having hydrocarbons chapter, and basically general organic chemistry we are going to see various effects: inductive effect, electromagnetic effect, hyperconjugation, resonance or mesomeric effect. All such effect we are going to deal. So today we are going to discuss a bit. I will not take much time. Yeah, we will start with this basics. So before going to that, a little bit history around this. Why we are having this organic chemistry as a separate branch? Carbon, as we know, there are nearly 120 elements are there in our periodic table, but this carbon containing compounds we are studying separately as an organic chemistry. But while the all other compounds of all other elements like you can say except this carbon and hydrogen, all other compounds, elements compound, they are studied as inorganic chemistry. So what is the reason behind that? We are having this much separate branch of this organic chemistry. Why we are studying? So the main reason, if we see the property of this carbon, this is because of the property of carbon, and that property is termed as catenation. Carbon forms a covalent bond with itself, a carbon-carbon bond. It is with other elements also, like nitrogen, oxygen, it will form. So generally it possesses the property of catenation. So that's why it is being studied separately. And a vast number of compounds are there of this carbon containing. More 99%, it will be like a surprise for you that 99 nearly compounds are organic compounds only which exist. So all the natural compounds which are in our body, in our cells, they are generally organic compounds only. So earlier in when even not that much advanced technology was not there, it was being assumed that these organic compounds, they cannot be synthesized in laboratory. Can't be synthesized in laboratory. Earlier it was being assumed that these compounds cannot be synthesized in the laboratory, but in 1828, the first compound which was being synthesized was urea. The first organic compound which was synthesized in the laboratory was urea, and that was being prepared from ammonium thiocyanate. Ammonium cyanate. NH4CNO. When it was being heated, and it gives us ammonia. The formula of ammonia is NH2C double bond O NH2. It is quite better if we write down it like this, because the bond is formed with nitrogen. So this is the history. And after this history, this discovery, various other compounds such as acetic acid was discovered by the Kolbe. So this was like a initiation of the organic compound synthesization in our chemistry laboratory. Earlier it was being assumed that we can only extract this compound from, you can say, the organic like living cycle only, and that's why they were being termed organic compound was termed as the living organism compound, or the compound which can be obtained from living organisms only. We cannot synthesize them. So the next thing which came, because there are a vast number of compounds are there, so we have to represent them. How can we represent them? Representation of organic compound. So up to that, what we have discussed up to now was just a brief history. You will see that from here the actual chapter starts. The representation of organic compound. So in inorganic chemistry also you might have studied about the Lewis structure, or you can say Lewis dot structure. If we are having a simple organic compound, that can be quite easily be represented by Lewis dot structure. If you are having a compound like ethane, or you can say methane, it composed of carbon, 4 electrons. These 4 electrons of carbon, these are electrons of carbon that are being shared with electron of hydrogen, and these are electron of hydrogen. So if you see over here at this side, so we can see this there is a sharing of electron. One electron sharing over here. So one electron sharing over here, and one more electron which is being shared over here. So this is CH4, like this. So we will go into the detail of this also. What is the representation? Like how we can represent this in 3D. That we are going to discuss in quite detail in the upcoming slides only. That how this is being represented. This is in this point we are going to discuss regarding the Lewis dot structure. So Lewis dot structure is being represented like this. If we are having ethane compound, which means CH3 single bond CH3, it will be represented like this, that we are having one carbon, we are having another carbon. So all the electron of carbon are being represented by this star type which I have drawn. It's just the way of representation only, and this hydrogen electron are being represented by dot. Yes. So I will just draw all these from single pen only. These are being shared like this, just to save the time. 4 bonds, and they are shared like this on a very quite better way. And regarding that, another this carbon, these 3 bonds over here, and that was the if we draw the opposite structure of this compound, because carbon here and 3 hydrogen are being attached, 1 2 3, and over 3 hydrogen are attached, 1 2 3. So this is the way how we can represent any number of compounds. So it is quite a hectic issue to draw. These are like very small structures are there, like methane or ethane. We can draw methanol, ethanol. But to draw this Lewis dot structure of a very lengthy compound such as camphor, so it would be very hectic and complexity will be arrived. So what we have done, we are having another type of structure representation, and that is like dash structure. Now, another way of representation is dash structure. So in this dash type of structure, what we are going to see, just we will do nothing, just we will see that these hydrogen will be replaced with this single bond. These electron representation which we are seeing over here, that will be we can say will be represented will be like you can say represented by a single line dash. This is like this. The electron which we were showing like dot and star, now that can be represented by these dash. So now we will be any number of compound which can be, and this type of like compound, they are like we can say it as a complete structural formula. This will be known as complete structural formula. This is the complete structural formula. In the dash, each and every atom is being represented over here. Yeah. So now again, if you see one or two more example of this is like the structure of ethane. So if we are having like some other compound like ethene, if we want to draw the ethene compound, so what we are going to do? Carbon, ethene composed of 2 carbon and 4 hydrogen, like this, and carbon have 2 double bond. This is the ethene complete structural formula. Complete structural formula of ethene. In the same way, if we have ethyne, for ethyne we will be having a structure like this. So this is the way how we can represent these organic compound in a complete structural formula. So if I will just try to again compare it with that the dot structure which we have drawn over here. Lewis dot structure of this compound, if you want to draw, it will be like this. like this. So this is the Lewis dot structure of ethene. Like this, the sharing of electron, one bond, second bond, and these are like this. And if we see regarding the ethine, so it can be represented like this for ethine. One bond, two bond, and three bond. So this is a quite hectic problem, like you are just making this dot and sometimes you will miss some dot. So it is quite it's not an appropriate way to write the lengthy or you can say complex structure compound. So this is quite better way. If you deal compared to this, it is quite better, like dash structure or complete structure formula of these compound. It is quite better than this. So now we will be seeing like condensed structure formula. Condensed structure formula. In the previous complete structure formula, we have seen that we have replaced the dot and you can say like star or dot which we have drawn. We have omitted, replaced that with the dash. So in this condensed structure formula, now we are going to do, we will replace this dash also. What we will do, we will omit this dash and we will most of the dash will be omitted. Like this is our compound CS2 double bond CS2. This is the condensed structural formula of ethene. What we have done over here, we have omitted these two hydrogens. Sometimes we will omit all these. You can write down also this thing. Omission of dash. Sometimes we will omit all the dash and sometimes some partial dash will be omitted. Like in the case, these dash we can remain over here like this. But sometimes we will omit all of the dash. Like if we take an example of ethane, it will be represented like this. CH3, CH3. Or it can be written like this also. CH3, CH3. Anyway, CH3, CH3. So in this way, if you see, earlier we were having this much bond. In this case, all these dash have been omitted. And this structure is condensed structural formula. This structure is condensed structural formula. Clear? So if you see some more example of this condensed structure formula, so we can say an example of, let's say, alcohol. If we are taking CH3, sorry, CH3OH. This is a condensed structure formula of methanol. Alcohol is being represented by OH, and that all those things we are going to study in this all playlist. It's the only first chapter lecture in this series. We are going to deal with all this in the series. After that, we are going to discuss regarding the classifications of this organic compound and their nomenclature. All of the things we are going to discuss in the upcoming lecture. So now, just at this time, we just need to know that this alcohol CH3OH. This is the condensed structural formula. So if you see dash structure of this, it is like this, OH. Or you can say complete structural formula. So yeah, so many more compound can be written like this. So we can have any number of compound, any lengthy compound. So we will discuss those in like when we will be discussing like the next, the bond line notation. bond line notation. In this type of notation, what we are going to do, we will show the carbon-carbon bond by a single bond, or you can say by a dash. And the carbon can be represented by dot. Simple dot will be like the representation of uh, you can say carbon. How we can represent it like this? CS3, CS2, 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 CS3. So this carbon bond will be shown by these dots. So this is the first way. I will just go into that the actual structure of this bond line notation. So just to make you understand how we will proceed into this. Actual structure was not like this. It is, if you see the complete structure, this is actually you can say uh, condensed structure type form, where we have omitted some of the dash. So but what we are going to do over here, carbon will be represented by dot, carbon carbon bond will be represented by dash, and some of compound like OH, NH, they will be represented by their, like nitrogen is there, oxygen is there, they will be represented as it is. And where nothing is there, we have to understood that the valency where there is nothing, which means the hydrogen is present over there. Like in this case, if you see this compound 1, 2, 5, 6, it is a hexane. For this hexane, what we will do? We will draw it like this. One, two, three, four, five, six. This is the bond line notation of hexane. So they are generally represented as zigzag, just because if they are in the state, how we can know where is the carbon. So each dot is carbon. Each dot is carbon. Clear? Each dot is represented by carbon. So this is the representation of hexane, which means this carbon, 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 carbon. 6 carbon are there. 1, 2, 3, 4, 5, 6. So where there is nothing, which means the hydrogen. 1 carbon, which means 3 hydrogen are there. So 2 carbon are there, which means 2 more hydrogen, because the carbon has a valency of 4, which means the tetravalent. Carbon is tetravalent. That is also another reason why we are having that much number of compound, because it is tetravalent and it makes 4 covalent bond, and a chain-like structure is being formed over here. Yeah. So coming back to this, so this is for 1, 2, 3, 4, 5, 6 hexane. This is being represented like this. So if you see some more example, just to understand this concept, if we are having this compound, just I am just trying to make you understand this concept quite better way, like 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon. So what we are going to do, we will not represent it like this, we will represent it like this: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So it is heptane. Bond line notation of heptane in the zigzag way. So if we are having some alcohol, it is cyclopentane. 5 carbon are there. 1, 2, 3, 4, 5. And if we open the structure, it is like this: CS2, 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 CS2. This is like a condensed structure. If you want to see the complete structural formula, then we have to draw it like this: CS2, 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 like this. So this is the way how we represent these condensed structure formula or complete structure formula. So many more compound can be represented like this. Any number of compound. So it will be quite better. We will also study this concept when we will be studying the nomenclature of like hydrocarbon. Then we will also discuss this concept in quite detail. So now I am going to show you the 3D representation of carbon, which I have promised you. Carbon is compound are not planar. Generally they are in 3D, which means the tetrahedral. So if this is the carbon, and these two bond like hydrogen and hydrogen. If these two are on the plane, which means on this board, this is carbon, this hydrogen, these three bonds are on this board only. So what will happen? The remaining two hydrogen or whatever the is being attached, they will be like above the plane and below the plane. This is being represented by above the plane and it is being represented as below the plane. So this is the representation of CH4. Quite better like this. Some other compound, if you are having CS3, this carbon CS3, CS3. Anything can be attached on this carbon, but it remains like this only. The representation, okay, sorry. The actual representation is like this only. Although we represent like this or anyway, but to make you understand, the actually compound, this carbon compound exists in this form, 3D. The three-dimensional structure of this carbon is tetrahedral. It's tetrahedral, and one more thing I can show you to make you understand in a better way. If so, let's see. If these bond don't consider that as a bond, this is a cube. If one hydrogen is at this side, another hydrogen at this side, one hydrogen at this center, and another hydrogen at this center. And over here the carbon. This is the tetrahedral structure of any carbon compound. So you can assume if this room, if it is a perfect cube, one hydrogen at this center, another hydrogen over there, and two carbon hydrogen will be in the downside. This center and this center, and two at this center and this center above the side. So the above the hydrogen are different in the below the hydrogen. Below hydrogen are in this plane, diagonal, and above hydrogen are in this diagonal. So in this way we can see this is the tetrahedral structure of the CH4 or any carbon compound which is having 4 bonds. Yeah, that is tetrahedral. So over here these two bonds, if we represent it like in this way, two bonds are in the plane, one is above the plane and another is below the plane. So this is like if I am standing over here and this let's say this is carbon, so this bond is like in the plane only, state wise this is one hydrogen, another hydrogen is below the plane. So one hydrogen over there, one hydrogen on the below the side. So what this is the carbon, one hydrogen over here, one hydrogen below the side. So one hydrogen will be like above the plane, one hydrogen will be the below the plane, like this. This one and that one. This one, yeah. So these are above the plane towards the observer and they are away from the observer. If someone is observing from that side, if someone is observing from that side, So one toward the observer and one will be the away from the observer. This is the way how we can represent this CH4 molecule. I will represent this CH4 molecule in the next class with the model also. That will be a better explanation also, and you will understand them in a better way. I will just try to provide that model, and I will just show you how these CH4 molecules are being arranged. So that's all for today. In the next class, we are going to discuss regarding classification of this organic compound, how these organic compound are being classified, and why are these organic compound are being classified. So that's all for today. Thank you everyone.